Let z of n be the complex number defined as zn equals n squared plus n plus 1 plus I for n belongs to natural numbers. Find arg z0. So z0 means that our n equals to 0. So z0 equals to 0 plus 0 plus 1. So it's just 1 plus I. And if we sketch this out in the argon diagram, we'll have 1 and then 1 here again. So our angle will be arctan 1 over 1 equals to arctan 1, which equals to pi over 4. And write down expression for arc 0 n in terms of n. So because n squared plus n plus 1 is always going to be positive, so we'll at least know it's going to be in like this, it'll be in the positive area. So it'll still be the opposite divided by the adjacent, except our adjacent this time is going to be n squared plus n plus 1. So arg 0 n equals to arctan 1 over n squared plus n plus 1. Okay. Bi show that arctan A plus arctan B equals to arctan A plus B over 1 minus AB. Okay, so let's put tan around this whole thing. So tan arctan A plus arctan B will be equal to, just remind you of the formula, I'll just write over here inside, tan A plus B equals to tan A plus minus tan B over 1 minus tan A tan B. This is in the formula booklet, by the way, so yeah. So our tan A, is going to be arctan A, and then our tan B is going to be arctan B. So our A is going to be arctan A and B is going to be arctan B. So tan arctan A plus tan arctan B over 1 minus tan arctan A, and then tan arctan B is going to equal to, because tan arctan A will just be A, and then tan arctan B is just B, so plus B, all over 1 minus AB. So our tan arctan A plus arctan B equals to A plus B over 1 minus A over B, and then arctan A minus plus arctan B, and B will be equal to arctan A plus B over 1 minus AB, because we move this to the other side. Hence or otherwise show that arg W1 equals to arctan 2. So so arg W1, well, I guess first W1 is can be shown here. So W of n is Z0 times Z1 times Zn. So W of 1 is going to be Z0 times Z1. So W1 equals to Z0 times Z1. So arg W1 is going to be arg Z0 plus arg Z1. because that's how complex numbers work. You add the angles when you're multiplying it together. So we know what Z0 is. It's just arctan 1. So equals to arctan 1 and then plus Z1. So we have this where expression of arc0 of n is given by arctan 1 over n squared plus n plus 1. And if n equals 1, so just arctan 1 over 3. So plus arctan 1 over 3. And using the thing we just proved here, that we showed here, arctan 1 plus arctan 3 is going to be equal to arctan 1 plus 1 over 3, and then divided by 1 minus 1 over 3 equals to arctan 4 over 3 divided by 1 minus 1 over 3, so 2 over 3 equals to arctan 4 over 3 divided by 2 over 3. Keep change flip, you'll end up getting arctan 2. So arc W1 equals to arctan 2. And then prove with mathematical induction that RW of n equals to arctan n plus 1 for n belongs to natural. So we'll start off with the statement. So let P of n be the statement arg W of n equals to arc tan n plus 1 for n belongs to natural numbers. So the first step will be to equate our n to like the first possible value. And because it's natural numbers, it'll be starting from 0, not 1. So P0 is true. Indeed. Arg W0 equals to, as we found over here, arg 0, arg Z0, which is equal to arc tan 1 equals to pi over 4. And then arctan n plus 1 is equal to 0 plus 1 is equal to arctan 1 equals to pi over 4, which equals to arg W0. Okay, and then assume P of k is true, where arg W of k equals to arc tan k plus 1. And then the next step is going to be claim pk plus 1 is true. That is arc wk equals to arc tan k plus 1 arc tan k plus 2. And then I'm going to start from the left hand side, so this value. So left hand side, arc wk plus 1 is equal to r w of k plus arg w of k plus 1. Again, because w is z0 times z1 times z da 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 da, you're adding the angles together. So arc wk plus arc wk plus 1. And then from here, we just slowly transform this into that. So we know arc wk is this, so equals to arc tan k plus 2. And we know, and we have how to write wk plus 1. It's 1 over n squared plus n plus 1. So, and then plus arc tan 1 over, so n squared, so k plus 1 squared plus n, so k plus 1 plus 1. And then again, using the previous identity we found, it'll be equal to arc tan, so our a is k plus 1, so k plus 1, and then our b is 1 over k plus 1 squared plus k plus 1 da da da. And then just to save time, 1 over k plus 1 squared plus k plus 1 plus 1 equals to 1 over k squared plus 2k, wait, plus 3k plus 3. So k plus 1 plus 1 over k squared plus 3k plus 3 all over 1 minus a, so k plus 1 times b, so 1 over k squared plus 3k plus 3. And then just need to start simplifying everything. And make sure you don't forget this arctan, because yeah, you might lose marks if you forget it. So arctan, and then k plus 1 times all this, so uh, k k cubed plus 3k squared plus, I'm just timesing this by this first, by the way, plus 3k plus k squared plus 3k plus 3, and then plus 1 because of this, all over k squared plus 3k plus 3, and then this all times 1 over, I'm just separating it so it's easier to see, so 1 over 1 minus k, so this just moves up here, so I'm going to do k squared plus 3k plus 3, and then minus k minus 1 because it's minus k plus 1. And then all this over k squared plus 3k plus 3. And then equals to arc tan k cubed plus 4k squared plus 6k plus 3 plus 1, so plus 4, over k squared plus 3k plus 3 times, so k squared plus 3k plus 3 minus k minus 1, so okay, so first case, this is like 1 divided by blank, so this can move up here, so k squared plus 3k plus 3 over k squared plus 2k and then plus 2. So then these ones can cancel out because k squared plus 3k plus 3 is in the numerator and denominator. So then we'll have equals to arc tan k cubed plus 4k squared plus 6k plus 4 over k squared plus 2k plus 2. And then if you did everything right, you can kind of just assume that this is going to be divisible by this, because it should eventually lead you to this form of k plus 2. So I'm just going to do long division just to see if it actually is. So k squared plus 2k plus 2, k cubed plus 4k squared plus 6k plus 4, and then okay, k, so then k cubed plus 2k squared plus 2k, and then all this subtracted, so it becomes 2k squared plus 6 minus 2, 4k plus 4, so then it's k plus 2. So then we'll know equals to arctan k plus 2, k squared plus 2k plus 2 all over k squared plus 2k plus 2. And then these cancels out, so we get equals to arctan k plus 2 equals to the right hand side. Ta-da. So then, very important, the last statement you gotta say after completing it. Therefore, by mathematical induction, the statement P of n is true for n belongs to natural numbers, since P of 0 is true and pk leads to pk plus 1. And then that's done.